So this is going to be the end result of our video. We've got a enemy that reacts pretty uniquely to our player with its own omnidirectional attack in order to try and counter him. And it moves around, tries and keeps itself at a safe distance until it's certain it can hit the player. So yeah, let's just get right into the video. Alright, so we got a lot to cover, so I'm just gonna go through things pretty fast this time. I'm kinda expecting that by now you're getting a decent understanding of how a lot of stuff works. So create a new scene, can make it a kinematic body 2D, and right now we're gonna name it a clone because that's the name I've decided to give to this enemy. Then on its collision layer, we want to set it to the third one, which is enemy, and for it to collide with the first one, which is the environment. And then that's all we have to do for this node. So then we add animation player, add a sprite, duplicate that, we'll call this the body, this the mask. I'll just put the sprite at the end of these to make it more obvious what they are. Create more nodes. We need a collision shape 2D, and we're gonna need a node 2D. We're gonna rename this raycast, and it's just gonna hold all the raycasts we use. So then we're gonna add a raycast 2D. And I'm gonna have 3 of these, and we'll just leave them like that for now. Then we're gonna need an area 2D and a collision shape 2D for that. We'll name this our attack range. Create another node, have one on timers, and we'll just duplicate this timer 4 times. We'll call the first one attack delay. Second one will be called attack time. Third one will be called charge delay. And the fourth one will be called walk dust create delay. Then we can go ahead and select all of them, do one shot, that'll put them all to one shot, and save this under scenes, enemies, clone. And then now we are going to drag our sprites that we need into this. So on our body sprite, drag in our body. I think, what was this, we have 7 V frames and 8 H frames. I think that's right. Let me just scroll through these. Seems right. Mask sprite. We are going to go into our enemy, drag in the enemy mask, and we'll just move this. We're just gonna have this at -1Y, and we'll go to our body sprite. Let me just change this to a frame, and I'm gonna hide our raycast so I can see what we're doing more. So there's our standing frame, and make the X on this -0.5, and the Y can be 3, and then we're also gonna go into visibility and modulate it. Now we're just gonna go to our collision shape 2D, create a new rectangle shape. Drag it in from the top and bottom. We'll need this to be transformed 0.75, I believe. I don't know, I remember trying to get a scale to work, but I couldn't, so I'll just go over to these 3 dots, turn pixel snap off, and then we're just gonna drag this in, and we can move it down by 2. Turn pixel snap back on, gonna want to move it up 1, then just make it go out 1, This is the shape you want to come by. You can have extent as 4 and 1.5, position 0 and 1. And that's it for the colors and shapes. So if we go into our animation player, new animation, do idle, autoplay at start, and just want to head over to our body sprite. We'll hide this. And now we're just going to key it at frame 3. 0.1 duration, do a new animation, not sure what the next one is, I think it's walking. Yeah, so I'll rename this walking, go back up to 6, key dot in, and change the snap to 0.075, and just drag it forward by 1, up the frame, key it till you have keyed the 10th frame, change the duration to 0.375, and turn looping on. And we've got our walking animation. Now we can do another new animation. I also don't know what this is going to be called. We'll rename it to in air. Let's change 12, yeah, so frame 12. We'll make it 0.1 seconds. Next, we are going to do the prepare attack animation. So key at frame 14. The snap will be 0.02. So let me just zoom in. I'm gonna go to the next key, go up to 15, key that, just gonna keep on keying it until you've seen that this, whatever this is, which is meant to be some sort of sword with a glow that then comes out of it. So once that's gone, frame 20 is the last one. So then we can make this 0.14 seconds long. New animation, stunned, should be good. So I'll just continue going up frames, keyframe 21, and 0.1 seconds should be fine. And just keyframe 22, 23, and you can make the animation 0.3 seconds long. Now we can do new animation, die. It's going to have a 0.1 second snap as well, and we just key it at frame 23, go up a frame, and key that, just continue keying it. You want to key it up to frame 30, and then just change its duration to 0.8, play that, see how it looks, decent. And that will be all the animations we're using for our animation player. So now we'll just switch it to idle, so that way we can see what else we're working with properly. And go to raycast, we're going to do ground cast. Make it enabled, it's just going to be colliding with the environment. Set our raycast to visible, move this down, and it will go 1.1. on the Y cast to. Then we've got our right player cast, which we are going to cast to Y 0 and X 140, set it to enabled. Then we're going to remove it from colliding with the environment, add it to colliding with the player, and we're going to make our left player cast, set Y to 0, X to negative 140, and do the same, make it collide with the player, and make sure to make it enabled. And that's our raycast we need, so we can just make those invisible again. And now we'll go down to our attack range, which we'll set to collide. It's going to be removed from any layer, and we're going to have it mask with the player, so it'll detect the player. And then for our collision shape, we're going to do new circle shape 2D, and it's going to have a radius of 12. So let me just hide that. Now we've just got our timers. So our attack delay is 0.14 long. Our attack time will be 0.3 seconds long. And our charge delay, we can leave it at 1. You'll see why later. And our walk dust create delay will be 0.075. So then now we can move on to making our script, and we're just going to delete this, and we're just going to set up our connections straight off the bat. So with attack range, we want to connect when a body enters it and when a body exits it. So we'll just put those there, and then for attack delay, we want to connect timeout, attack time connect timeout, charge delay connect the timeout, and walk dust create delay, we're going to connect the timeout. And just group all of these together. Well, not these. We'll separate the timers and this area 2D connections. So in the area 2D, I guess I haven't explained yet, it's basically like a physics body that won't collide with anything, but it detects for overlapping stuff rather than collisions. So it's good for using stuff like poisonous areas, or in our case we're using it to detect something that comes within an area for the player, so that way we know whether it's close enough to be attacked. And you can use it for other things as well, like save points, and there's really just like a ton of possibilities, just up to you to decide how to use it. So now we'll move on to declaring some variables. So I'm going to start with an enum, add in those curly brackets, and these will be our states within the enemy. So we're going to have the combat state, the attacking state, the stunned state, and the dead state. Then we can move farther down and have an export variable, so that way it's going to be publicly available as long as something has access to the clone itself. So export var state is equal to combat at first. Export var health is equal to 5 for now. Then we'll do const large. What's going on here? Yeah, melee is equal to preload large melee.tscn const walking dust is equal to preload walking dust. Is that not what I named it? Yeah, no, just wasn't showing up the autocomplete. Const jump land dust is equal to preload jump land dust.tscn, and that's the constants we're going to be using. So we're reusing stuff we've already made, and you want to try and do that as much as you can with code, because that way it keeps it in a smaller package and, you know, less stuff to access at the same time. Makes it run better. So now we'll have var onGrand is equal to false, var motion is equal to vector2 0 0, var gravity is equal to 150, var acceleration is equal to 850, var max speed is equal to 700 via friction is equal to 200, and that's going to be for all of our movements. So we're going to create a new variable line. So via can see player is equal to false, var can charge is equal to false, var backing up is equal to false, var attack direction is equal to string null. Sorry, doesn't really matter what you put in here for starters, but just make sure it's a string. Then we've got var attack angle is equal to vector 2 0 0, var current attack is equal to null, var player in area, I know it's a lot of variables, and we'll set that equal to false. And we've got onReady variables to declare now. onReady var mask sprite is equal to money mask sprite. onReady, making so many spelling mistakes, I'm disappointed in myself. onReady var body sprite is equal to money body sprite. onReady var animation player is equal to money animation player. onReady var ground cast is equal to money ground cast. onReady var right player cast is equal to money right player cast. onReady var left player cast is equal to money left player cast. Now our timers, onReady var attack delay is equal to money attack delay. onReady var attack time is equal to money attack time. onReady var charge delay is equal to money charge delay. onReady var walk dust create delay is equal to money walk dust create delay. Oh yeah, that's our variables done. So yeah, I know it's a lot already on line 45 just from the variables we're making. But now we can just get straight on to how the code works. So, I'm gonna go func physics process, and then if state is not equal to dead, so as long as we're not dead, then we're gonna go through a massive amount of code here, not really massive, but handle ourselves while we're alive. So if on ground is equal to true, then gravity is equal to 150, else if gravity is smaller than 200, gravity plus equals 2, then we'll go back, then motion dot y plus equals gravity times delta. I've got another new line of code. If can see player is equal to false and backing up is equal to false, then if motion dot x is smaller than 10, and this right here is our friction that we're coding, motion dot x plus equals friction times delta times 1.5 elif motion.x is bigger than 10, motion.x minus equals friction times delta times 1.5. If motion.x is smaller than or equal to 10 and motion.x is bigger than or equal to 10, then motion.x is equal to 0. So that's our basic friction we got set up. So then we can just copy and paste this, it'll make things easier. And we'll change this to else, and we're going to remove the times 1.5s on both of these, and that's it. And so this right here would be our basic friction, but for some reason when I was making this enemy, the motion.x would increase on one side faster than the other. Maybe I just did some sort of weird mistake, I don't know, but this should fix it. And it's a little weird. If you guys end up spotting my error that I've made, then be free to tell me, and I'll do a correction of it. So then, another line of code, match state. We are in combat mode, then if can charge is equal to false, then var charge delay time is equal to randi %5 plus 1. So this will give us a random value between 1 and 5. I'm gonna go charge delay time divide equals by 100.0. The 0.0 is important because when you do math, if you have two whole numbers in code, then it's not going to return a decimal, it'll just round it to the nearest number. And if we're dividing it by 100, that nearest number is going to be 0 all the time, and well, that's not very helpful to us. So even adding in that 0.0 will allow it to do math with decimals. So then we go charge delay dot start charge delay time. So when we before we start moving towards the player, what we're going to do is just create a very small random time in which our enemy will do nothing before they start moving towards them. And this creates a bit of a reaction time variety, not one to affect the player's timing at all, but more just if you have enemies that end up getting stacked up on top of each other, this will help them separate, as well as the fact that it'll make them feel less robotic, even in the subtleties of fractions of seconds, with differences of reactions. Just showing that they're not all the same can really help push combat when it's up against AIs further, so adding in a bit of randomness to their behavior, because like in combat against players, you can't always predict what they're gonna do. That's what makes it a lot more fun. But of course, this being a fast-paced game about precision and everything, can't have any like completely random behaviors. So now what we do is check can advance. It's going to be a function. We're going to pass in delta. So now we're going to have to declare that, otherwise we're going to have an annoying error message there for a while. So we'll do func check can advance delta, and just put in pass for now. And we'll also put in func check where to go, which will take in delta, and put another pass there. So back up here, if can see player, is equal to false, then check where to go, delta. Elif walk dust create delay dot is stopped, then walk dust create delay dot start. So then the way I've designed this enemy is that when they have a horizontal direct view of the player, they are going to just run at them really fast, and if the player is in the air, then they're just going to either slowly walk forward or backwards in order to give themselves a decent distance to the player, just enough so that the player can reach them, but not enough so that the player can just kind of aim in their general direction and hit them. And then we can go into attacking. Pass. Might end up removing this later. I don't even know if it's going to get used. And stunned. Pass. In fact, we will remove the attacking, but we'll keep the stunned in because I might use that later when we create our possession mechanic for this game. So then, 2 indents in, we're going to do update on ground and animate. I'm also going to do if body sprite dot flip h is equal to false, body sprite dot I'm just going to add in, what did I do wrong? Okay, I need second equals. So body sprite dot position is equal to negative 0.5 else body sprite dot position is equal to 0.5. No, this will have to be position dot x actually. Nope, I've got to put in the 0 there, and that's supposed to be positive. So then we've also got finally motion.x is equal to clamp motion.x negative max speed, and finally motion is equal to move and slide motion vector 2 0 negative 1, and that's our physics process absolutely done. So now we can go and declare new functions, update on ground, which we'll just put in pass, and then func animate, which we will also put in pass. Now in our update on ground, I'm going to do if groundcast.is colliding, then if on ground is equal to false, var jump land dust. What's wrong with this? Oh, is equal to jump land dust dot instance get parent dot add child jump land dust dot global position is equal to self dot global position plus vector 2 0 5.75. Okay, so then what this does is we're just checking whether we're on the ground, and if we were, then we'll go into this function, and if we weren't the last frame, then what we're going to do is just create this land dust which we've previously set up, and then afterwards we're going to state that on ground is now equal to true. And that way we don't need to make a was on ground variable, which does make it, it's got its advantages and disadvantages. Like, it's not really disadvantageous at all, actually. It's just like maybe 2-3 extra lines of code or something, but you only really need to do it if you need something to be aware of it outside of what's going on in whatever figures out whether you're on the ground or not. So since we don't need anything like that, we can just use this method, which just right before we declare it to be equal to true, we'll check if it was equal to false. So then we can add this stuff in. And the 5.75, since I decided to put the update on ground after we handle all of our motion, if the enemy is jumping or landing, they'll be at different heights. So then this is a good height for landing, because that way it's guaranteed that it'll be firmly into the ground. Meanwhile, when we go over and do our else function, we can just copy paste this stuff, change this to true and the other thing to false. Meanwhile with this though, we'll also need the 6.75 because we would have just left the ground already, and we're a little bit off from being flat on our ground. So now we can just close this, go into animate, and we'll do if state is not equal to attacking and state is not equal to stunned and state is not equal to dead, then if global this was something I forgot to set up, just pass for now, and we're gonna go and get in this file. We're gonna go new script and we're gonna call it global data. And in our global data, we'll go var player, I think. And we'll just go var player is equal to null. Then in our player script, I'll just scroll up, and in its ready function, we're going to create a ready function. We'll just put pass for now. We go into project settings, auto load, then we're going to click on this folder right here, double click our global data, I'm just going to add, and what this does is it creates an auto loaded singleton. So it'll automatically get loaded at the start no matter what, and everything has access to it. So even though we are in our player script right now, we can just go ahead and do global data dot player, so we already have access to that variable, is equal to self. And then we can go into our clone, and then we're going to go if global data dot player dot global position dot x is bigger than self dot global position dot x, then mask sprite dot flip h is equal to true, masks body sprite dot flip h is equal to true. Actually, sorry, this is supposed to be false. And then lf global data dot player dot global position dot x is smaller than self dot global position dot x, mask sprite dot flip h is equal to true, body sprite dot flip h is equal to true. So then we can move on and go if on ground Oh, actually, we want this to be 2 spaced up. So then if on ground is equal to true, then if motion.x is equal to 0, animation player dot play idle, else if backing up is equal to false, animation player dot play walking, else animation player dot play backwards walking. And what played backwards does is it literally just plays it backwards from the start, from the end to the start. So then when we're walking backwards, it'll have it look like we're walking backwards. Pretty straightforward stuff. Else animation player dot play in air. So I'll just close that. So we're also just gonna put in a func receive damage function, and we're gonna have damage amount, damage type, and if current attack is not equal to null. So right now, if we have an attack that's loaded, then our current attack will Q3. That way, if we have an attack and we get hit, then our attack's just gonna cancel out. Well, the enemy's attack will cancel out if they get hit by the player. That way, well, if the player, since it's a melee game, we don't want the player to get hit right after they land a hit. And then we'll go if attack delay dot is stopped is equal to false, then attack delay dot stop attack time dot start, and this will just make it so that if we are attack delay, which is very short anyway, but still doing it, then that way if we attack, then it's only going to take 0.14 seconds before they decide to attack. So if they were right about to attack and they get hit, then they're also going to have to restart that attack, giving the player more time to escape from their attack. So we can close that, and we're going to go into our check can advance, and if state is equal to combat and charge delay dot is stopped, then we're gonna go if right player cast dot is colliding, and if on ground is equal to true, motion.x plus equals acceleration times delta, and then we'll go can C player is equal to true, else can C player is equal to false, and then we'll also put in an elif statement, left cast dot is colliding, then if on ground is equal to true, motion.x minus equals acceleration times delta, can C player is equal to true. Then in our else we'll go if can C player is equal to true. So this is basically the same thing we did in our update on ground with checking the value of something before we change it. Then what we're going to do is go var jump chance is equal to randi %3, and and then if jump chance is equal to 0 and on ground is equal to true, motion.y minus equals 100. So then if the player leaves our viewing range, then what's going to happen is there'll be a 1 in 3 chance that our enemy will decide to jump, and since our viewing range only goes around in one flat way sideways, like it doesn't cover all of this area, then if the player jumps trying to like jump over our enemy, or maybe they decide to jump up and then want to dash down on them, then there's also a chance that our enemy will jump up and meet them, so they gotta be prepared for that. Then we're gonna do if on ground is equal to false, if global data dot player dot global position dot x is bigger than self dot global position dot x, then motion dot x plus equals acceleration times delta, else motion dot x minus equals acceleration times delta. So this just makes it that our enemy will move when they're in the air after they've jumped in a direction. So now when I check where to go, this is where we're going to handle whether we're backing up or moving in slower than normal. We're going to go if to local global data dot player dot global position. The toLocal function just compares our own position to the true 0 and the player's position to the true 0, and then that way we will be able to figure out the local position as if it was a child of this, and it can be easier to work with some math that way. So then we're going to go dot x and is bigger than 0 and to local global data dot player dot global position dot x is smaller than 40, motion dot x is equal to negative acceleration times delta, backing up is equal to true, lf to local global data dot player dot global position dot x is smaller than 0 and to local global data dot player dot global position dot x is bigger than negative 40, motion dot x is equal to acceleration times delta, backing up is equal to true, and then else backing up is equal to false if to local global data dot player position dot x is bigger than 65, then motion dot x is equal to acceleration times 2 times delta, if to local global data dot player position dot x is smaller than -65, then motion dot x is equal to negative acceleration times 2 times delta. Okay, so quick explanation of this code. First, if you look in our physics process, it's only going to call this if we can't see the player, which means they're either above us or out of our range. If they are within 40 spaces to the left or right of us, this is for if they're to the right of us, and this is to check if they're to the left of us, then we're going to move in the opposite way by a small amount, and otherwise, if they are farther than 65 spaces away from us, then we are going to advance at a slower pace than our walking, but we are going to be moving at a faster pace than our backing up. In our on attack range body entered, we're going to check if the body that has entered dot is in group player or player in area is equal to true. I think I did 2 spaces there. Yeah. So then player in area is equal to true. Motion.x gets divided by 2, and state is equal to attacking attack delay dot start, and you could add a randomness to this, but I would advise against it, since it's basically once our player gets within a certain distance to them, it's best for them to know a consistent amount of time that they will have, since it's more crucial about whether they're taking damage compared to this charge delay, because it'll be from when they're farther away, and it's working in the benefit of the player because it's giving them more time, rather than if you were to make the other thing random. It might give them more time in some cases, but either way it makes it rather inconsistent, which when it's with something like this, it just doesn't really work that well. So then animation player dot play prepare attack angle. Change this to attack angle rather than attack dangle. Is equal to local global data dot player dot global position if global data dot player dot global position is bigger than self dot global position dot x, and dot x here, then colon and attack direction is equal to right, else attack direction is equal to left. Then in our attack range body exited, if body dot is in group player in area is equal to false. And the reason we're doing this player in area is because initially the code just checks to see if the player just has entered the area, so then it would then respond with attacking the player, but then if the player continues to stay in the area, then it's gonna do nothing. So then rather than that, we just have it that the player will be continuously in that area until, well, they leave. And what we are gonna do is, since this is like a setup for our attack, so then having this OR function also makes it so that when we call it, if the player's in our area as well, then we can run through this code. So then now if we go into our on attack delay timeout, we'll do motion.x, it's divided by 2, and var large melee is equal to large melee dot instance self dot add child large melee current attack is equal to large melee. That way we have something for the current attack to be. Otherwise this code is basically a repeat of what you've seen in our player though. So however, we also add in var attack angle modifier x is equal to Randy 8 minus 4 var attack angle modifier y is equal to Randy percent 8 minus 4, and then we'll do attack angle dot x, attack angle dot x plus equals attack angle modifier x and attack angle y plus equals attack angle modifier y. So now whenever our enemy attacks the player, there'll be a bit of an offset to how they attack, so they don't always attack perfectly, which will help them feel weaker, so that way it can help our player feel stronger and more refined. However, we still need to make it consistent enough so that the player will get hit. So then large melee dot rotation is equal to attack angle dot normalized, then I forgot a line, large melee dot position is equal to attack angle dot attack angle dot normalized times 5, and this is actually attack angle dot angle, and then we do large melee dot creation false, since this will be created by the enemy. Dark red, I can't remember where we added that in yet or not. I will check after this. Attack angle, attack direction 1, and it will be physical type damage. Then we'll do animation player dot play idle attack time dot start. So now just head into our large melee script. We have not done our dark red, so I'm just going to change this white to dark red, and just copy paste our modulate value in here, and then now we head back into our clone script, and we'll go on attack time timeout state is equal to combat can charge is equal to false if player in area is equal to false, is equal to true, then then on attack delay timeout, pass in ourself, which really only gets used to check if the body is in a group, but we need it to be of a node that can be in the group, which is why we pass in ourself. We have it in null. What is this? On attack delay timeout. No, on attack, what is it? Range body entered? Okay. Then I forgot to connect our timeout from our charge delay, so we'll just do that. Move it in here. And then can charge is equal to true. And then if on ground is equal to true, then motion.x is not equal to 0. Var walking dust is equal to walking dust dot instance get parent dot add child walking dust dot global position is equal to self dot global position plus vector 2 0 5 walking dust dot creation mask sprite dot flip h, and that is it. So it took about 200 lines of code. How long is that players? 246, this is 228, so nearly as long as our player, in order to make this enemy, which is pretty, handles itself fairly well. So if we go into our node 2D, instance in our clone, we'll just gotta turn that off, bring them in here, turn this back on, run our game, and something's already wrong. Invalid get index player position. I needed player dot global position, player dot global position. Hopefully it works now. And yeah, except for our attack doesn't seem to be working, but he's jumping sometimes, sometimes not. He's backing up, and yeah, otherwise he's working. So we just gotta get that attack working. He's a little glitchier than the other one I made. We'll just do print hi. So it seems to be working with the right thing. Did we end up adding our... We didn't add our player to the player group. That's the problem. Okay, so hopefully it works now. Oh, already a problem. We don't have a player to set up to receive damage, so I guess I haven't explained groups yet either. So basically, we went into our inspector, we go to the node, and it's normally in signals. We can just change it to groups, and then you can do literally anything you want, and you just add, and that will add that node to the group. And then you can, in scripts, you can check if a node is in a group, and that way you've got like organization, and you can tell what specific things are. Definitely a great feature in Godot. So then in our player, we just got them in the player group, and our clone we should add to the enemy group. Otherwise we gotta put in a receive damage function. So func receive damage amount, damage type, and then we'll just have it pass for now. Now let's check it out. Still not working. I might have spelt it wrong. I did spell it wrong. hopefully it works now. Yeah, it's working. So we've got our enemy, which chases after us, faster on the ground, will try and jump up after us, kind of blocking our way sometimes, and we can, there's no collision yet with the attacks properly set up, but they are connecting properly, so it's fairly easy to set that up, but I won't do it in this video, because well, my voice is getting sore, and we've already gone on for quite a while, I think. That'll be it for this video. I thank you for taking the time to watch it. If you have any questions at all, please feel free to comment them. And yeah, if you like my content, consider liking this video or subscribing to the channel. It motivates me to make more of it. And have a good day.